Welcome to day 95. Today, we're going to talk about a major security blind spot for a lot of teams out there: model extraction attacks.
You know, a lot of us think that if we serve our proprietary model behind an API, it's safe. It's like a secret recipe locked away in a kitchen. But here's the question. Is that API really a vault, or is it more of a service window that a clever attacker can use against you?
Well, in the next few minutes, we're going to break down exactly how this heist works. You'll see how someone can clone a really complex model just by acting like a very persistent customer.
To get the intuition, let's forget about code for a minute. Let's stick with that analogy of stealing a secret recipe.
Okay, so imagine this. There's a secret sauce you want to replicate. The kitchen is totally off limits. It's a black box. The only thing you can do is go to the restaurant and order from the public menu.
So what do? Well, you'd become their most dedicated customer. You'd order every single dish that uses that sauce, you'd carefully analyze the ingredients on the plate, those are your inputs, and then you'd taste the final sauce. That's your output. After you've done this enough times, you've built a pretty big data set of these input-output pairs. And with that data, you can start to reverse engineer a recipe that tastes almost exactly the same.
Now, this analogy maps perfectly to what happens in the tech world. This secret recipe? That's your proprietary AI model. Ordering all those dishes? That's just like sending thousands of queries to the model's API. And that new recipe you created? We call that a surrogate model. It's a functional clone of the original.
All right, so let's translate that idea into the actual technical steps of a model extraction attack.
So what is it? Formally, it's an attempt to copy a model by just using it. An attacker sends it inputs, observes the outputs, and uses that information to build a copycat. The key here is they're not breaking in. They're using the system exactly as it was intended, just for a completely different purpose.
The process itself is surprisingly simple. Step 1, the attacker just hammers the API with thousands, sometimes millions of queries. Step 2, for every query they send, they carefully log the model's response. Now they've got this huge data set of input-output pairs. Step 3, they take that data and use it to train their own new model. And finally, Step 4, that new surrogate model now behaves almost identically to the original.
And look, this is not just some theoretical idea. This has happened in the real world. A perfect example of this is the GPT-4all project.
So the team behind GPT-4all wanted to build their own open-source AI assistant. To get the data, they simply queried OpenAI's GPT 3.5 Turbo API over and over again until they had 1 million prompt and response pairs. And the total API bill for collecting all that data? Just $500. But here's where it gets even crazier. Once they had that data, it cost them just $100 more to fine-tune an existing open-source model, Llama, and create their own chatbot. Think about that. A model that costs millions of dollars to develop had its capabilities pretty much stolen for a few $100s. The barrier to entry here is just shockingly low.
So, why should you, as an engineer or a data scientist, really care about this? Well, the consequences are a lot bigger than just losing a bit of a competitive edge.
First off, it's straight-up intellectual property theft. All that time and money you spent building your model can be wiped out for pocket change. Second, once an attacker has a copy of your model, they can study it offline to find other security holes. And finally, that cloned model can be used for all sorts of malicious things that you never, ever intended.
And we've seen this play out. When the parameters for Meta's Llama model got out, it was immediately repurposed to generate things like fake news and disinformation. Once your model is out in the wild, you have zero control over what people do with it. Okay, so the good news is you are not defenseless here. There are some really concrete things you can do to make these attacks a lot more difficult. The first line of defense is the basics, putting rate limits on your API and actually monitoring usage for strange patterns. But you can get more advanced. You can start to actively trick the attacker. For instance, if you detect a suspicious query, you could return a random, useless answer. You can even watermark your model by training it to give a very specific, weirdly incorrect answer to a super rare query. That way, if you ever see that unique wrong answer pop up somewhere else, it's like a fingerprint proving your model was stolen.
So, to wrap it all up in one sentence, a model extraction attack clones a proprietary AI by cleverly treating its public API as a massive open data source.
And if you remember only one thing today, make it this. An API is not a fortress, it's a doorway. And it's a doorway that you have to actively monitor and defend.
So I'll leave you with a practical question to think about. Now that you know how this heist actually works,
How secure is your vault?